Right, well, thank you all for coming along to my brown bag session after bullying other people into doing them, and thought I might as well do one myself. So today I'm going to talk to you about a project I worked on at my previous job, which was the West Midlands Fire Service, where I developed a mobile workflow application that would be used by staff out in the field. So first, a bit of background. It's started about just over a year ago. I've been learning Android in the spare time, just as a new technology to pick up. So I've been tinkering with various aspects of that, the UI, how things fit together, data synchronization, the typical sort of things that you'd want to look at in a mobile app. And that was going well, and coincided with a request that came into the IT department at the Fire Service. Now, West Midlands Fire Service had an in-house software development team of about 12 people. Part of what they did was develop applications used by the fire service, but also provide those applications to other fire services as part of supply partnerships. And one of those other fire services we partnered with was Staffordshire Fire and Rescue Service. Now they came to us and said, we've got your existing web-based workflow application. We now want a mobile version of that, and so it coincided quite nicely with me having done a bit of Android learning experimentation. To go, that would work. We could do that. So that sort of got the ball rolling with a bit of a prototype application. See if it would meet their needs, and then take it forward to fuller development. Now, the initial use case that they wanted for was to do this thing called home fire safety checks. What are they, you ask? They are where firefighters go out to little old ladies in their homes and say, you need a smoke alarm here, and glue one to the ceiling. It's a bit more involved than that, but that's the basic premise. They go along, ask them a series of questions. Does anybody smoke? Does anybody have mobility issues? Assess the risks that are on the home. Or you've got 47 things plugged into these extension bars here. That's a bit of a fire risk. And the way they do that is have essentially a questionnaire with a series of things they have to ask on there. If you answer yes to this one, then ask them these questions, otherwise ask them these ones. As I said, we had a web-based workflow application that provided this, but it was tied, needed a full web browser to do it. It wasn't mobile specific. It was be used, within on site essentially, rather than out in the field. So what they were doing is they were printing off essentially job sheets. People were going around to houses, writing all this down, and then when they're coming back to the station or the office, then typing it all up. Hence the need for a mobile application that would encompass that logic and automatically send the data back. So what they wanted, let's say, was a mobile version of that. They attempted to use the web-based one using laptops with a data card, but because it wasn't mobile optimized, it wasn't particularly useful, and there are issues with data connectivity when they're out and about. So they need something that would automatically synchronize the jobs and the data collected, so that they could just pick up the device, the tablet, have the list of jobs and go out and do them, and not have to worry about manually submitting that information back. That would integrate with our existing systems. As I said, we already had a web-based workflow, so we didn't want to have two separate systems. We wanted to jobs to be generated from that and data to be sent back into it. They needed multi-user support because they weren't issuing tablets to every member of staff. They were issued to teams, and then whoever was on duty would pick the tablet up, get their sign into it, get their list of jobs, and away they go. And whilst initially they wanted it to do the home fire safety checks, they had a number of other use cases they wanted to do. So they wanted to be able to handle more than one workflow essentially. So it would need to have dynamic UI, so it wasn't hard coded. You just doing the one set of questions and bullet points. As I forgot to remove that one when I was editing this. So there was a server component to it, and this is the high-level diagram for that, which is not very meaningful, but that's the most. So the server bit here interacts with the Android clients and the synchronizes with the existing systems they've got. As the usual sort of things, data access objects, authentication bits, typical stuff. But that's not what we're here to talk about. We're here to talk about the Android client. So we'll move on to. So what did it need to do? It needed to display a list of jobs. So they pick it up and go, right, here's the 10 jobs I need to do today. They go out, first job, Mrs. Miggins, 23 the High Street, we'll drive out there and launch into the task there. And so from that job, from that list of jobs, they select the one they're going to do, and it would then take them into the full workflow. Now, as well as that list of predefined jobs, which would come back by people calling into the fire service call centre or applying online and say, yes, I'd like a home fire safety check. When they're out and about doing this, they often have people in the neighbourhood saying, can I have one of these checks as well? So as well as having the predefined job list, they also have to be able to create ad hoc jobs. So it would need to know about the various workflows that were available. So they could go, right, I'm going to do a new activity system, a new home fire safety check job, or one of the other jobs that are available. Now, as I mentioned earlier, the actual process of the home fire safety check is primarily a series of questions, but it's not just answer all the questions in turn. If the occupant answered yes to, does anybody have mobility issues, then there's a whole series of extra questions to ask to get more information about that. And so rather than having to have the staff know which questions they had to ask and which they didn't, the application should or take them through the flow. So the best way of achieving that was have a wizard-style interface. So on screen, set questions related to the topic, answer those, click next, go to the next screen. If they answered yes to this one, then show them that page. If not, show them the next one. And it was also intended to make the application easier to use. And so one of the key bits was they had to automatically synchronise the data when they're out and about. They're not necessarily going to have a data connection all the time, so it would need to be able to store any data captured until there was a data connectivity, whether that was back in a 3G coverage or within Wi-Fi back in the base station. And so we would have to be able to retrieve a list of jobs when it was had coverage and submit them when it had coverage, but also work without data. Now, just a bit more about the wizard style workflow. So, I'm sure we'll have our own ideas what that means, but in this context, the application would essentially display a series of pages, have a header, standard navigation, next and previous buttons at the bottom, and then a dynamic area for the content. And it would do the standard thing, so validate those, the inputs, so if you click next and the field is required, tell you about that. And also handle multiple flows through the application. So what we have is essentially a core application that will handle the navigation, the validation, things like that, but doesn't necessarily know what it is it needs to display on any given page. That has to be defined somewhere, and the work and what the set pages are and what's on them. So we need some way of representing a workflow, what the pages are and what data items need to be displayed and captured on each of those pages. Now, all this is very, is pretty standard from a web development point of view. It's quite easy to knock up a quick web app that has a template and stick some new content in there with the forms and the validation, click through it and call it done. But because of the data connectivity issue, we couldn't just go for a mobile web app or just a skin, wrapping up using an Android web view and wrapping a website up into a little Android app, because we need to be able to function without the data. So, what could we have done? Well, we could have concentrated just on this one workflow and developed a completely native application just for doing that. So that would then be installed onto the devices. So you just code it up with as a standard Android app and say this page and this page and this page, and that would have got the job done, but it wouldn't have been any time there were any changes to the list of questions, and obviously you've got to develop and deploy the application again, and when they've got 30 or 40 devices out in the field, getting them all back in to redeploy the app and so on, and make sure everybody's using the right version is going to be problematic. And as I said, we could have used HTML for the UI. We could have done it as a web app, customised it for mobile, but you have the data connection issues. Although HTML5 does offer some offline functionality, so that there's certainly the option now that you could have developed it as a web app using the data storage functionality, but there are trade-offs to going with a web app on a mobile device. One of the main ones being that it doesn't have a native UI widgets, so it obviously looks like a web app as opposed to something designed for Android or iOS. And if you use one of the frameworks out there that are tailored for mobile app development, then they tend to either obviously be targeted at iOS or Android and then look funny on the other platforms. Now, so it's decided that we go for a hybrid approach of having a native application, but using a task definition of the workflow to say what the widgets are going to be displayed on screen and generate them automatically. Now, Android applications use XML to define the UI with Java code objects behind those, and they essentially, the XML gets inflated into native widgets, so you can build your application. You can define components as a section of XML and a bit of code, and they get inflated into native widgets as required in the application. You can build up your UI from those bits. So what we could have done is, so right, well, we'll just use that. We'll just define the workflow using XML on the server, send that across to the client and have it inflated on the go. There are issues with that approach because the XML definitions are quite bulky and verbose. They're dealing with a lot of things that are specific to Android UI layout, and so wouldn't necessarily make the most efficient wire protocol. And also you'd be tying your workflow to how Android does things. So if at a later date it said, oh, we need a Windows Phone client or an iOS client, we'd have a big translation problem of going, right, we have all our definitions as Android screens, how do we then create iOS ones for that? So we need something that's a bit more generic to decouple the workflow from the technology being used to display it. So what we decided to go with was a custom markup that would just define the workflow. Would consist of so a given workflow would consist of a number of pages, which would contain various data items, inputs for to be displayed on screen, and then we'd have the application would read in that definition and convert it to business objects and UI widgets as appropriate. So we'll come on to a very high-level view of what the mobile application looks like. Over on the left-hand side, we have the ubiquitous cloud. That's where all the data comes from. So we're on the other side of that is the server component, which handles creating a list of jobs and receiving the data back. In this instance, we're using a REST-based API for that, but Android supports whatever methods you want to use. The next thing on there is the SyncAdapter. Now this is one of Android's built-in bits of functionality. Rather than your application having to constantly maintain the network state and go, oh, is there something there? Is there a network there? Can I send some data now? Android has events and lifecycle management built in for that. So you, in your application, you implement the SyncAdapter and say, I want to be able to, when I invoke this, it's going to be doing something with the network, and Android will say, oh, well, there's no network now, I'll try again in a little bit. Oh, it's still no network, I'll try again a little bit later. So it'll reduce the number of requests and maintain and manage that for you. Now it's great because it means your application doesn't have to worry about that logic. You can just say, right, make this connection, or call this remote method, and you'll either get the information back, or you'll come back some point in time when there is connectivity. And what that means is you can invoke, make a request. Say, get me a list of jobs, and it's a fire and forget thing essentially. And the system may go, well, actually, we've only just invoked that. I won't try it again for 30 seconds. But it also means you can set that as a background process. So you can just say, here's a process I want you to run automatically in the background, so getting the list of jobs, and your application then doesn't have to worry about it. The system will manage that for you, and when there's connectivity, a request will go through, you'll get the value back, and then it'll call that event on your application and say, right, now you can process the stuff that's come back. So what happens then is we've made our request and data's come back. It passes on to the next section, which is the content provider. This is another aspect of Android applications. There are multiple ways you can store data in Android. There are various in-memory stores. You can have a file-based store, or you can have a SQLite database, which is the approach we went for with this application. We're having reasonably structured data coming across the task definitions, the job instances, and the data items that are stored with them. So they get stored into a SQLite database on the device there. And the content provider is a way of managing that, so that will has functionality in there for defining what the database looks like, what things are going to be storing in that. It also manages the writing to and reading from the database for you. So as the SyncAdapter registers with the content provider and says, right, requests come in, processes that into something you're going to store, and then calls the content provider, which will just store it for you. On the other side of that, in the UI side, in the activity up here, you have a list, a screen that is your list of jobs, for example. And that is also registered with the content provider as a receiver. And when the data is updated, automatically notifies the receiver, and will update the list accordingly. So in the background, you have a sync process going. So get me the list of jobs. That comes in, database gets updated, and then automatically the client, so if the user was looking at the list of jobs when the sync process ran, they'd automatically see that update without them having to refresh it or do anything manually for that. It's one of the key requirements of this was that it should be as little user requirement in getting the jobs and sending the data back as possible. All they're interested in is entering the data and moving on to the next one. And it works the other way as well. So if when the users entered some data and the job's completed, that's stored in the database here, and that notifies the SyncAdapter and says, okay, there's been some changes here. It looks through, goes, right, all these jobs are marked as completed. I'll make a request to send those back to the server. And again, that would be the actual request will be managed by Android itself. So say, right, here's stuff I need to send back, and when there's data connectivity, it'll get sent, and any response back from the server will then come to the SyncAdapter for it to handle. So any error conditions, from the server will be notified back that way. In the middle here, I've got the JSON parser, because that's used in a couple of places. When in order to make the synchronization process as quick as possible, the task definitions, which are in JSON format, and I'll cover that in a bit more detail soon, come into the SyncAdapter, and we need to get, and they're rather than being parsed fully into an object model, we're just parsing some metadata from them. So, what's the name of this task? What's this job? And then, but the actual JSON definition is stored in the database, and then that is processed when needed by the actual business logic here. So the JSON parser is used by both sides of it. The Android applications are made up of what are called activities. So one application could have multiple activities, and in broadest sense, represent a screen or state within your application. So in this case, we have an activity displaying a list of jobs, an activity for authentication and preferences, and an activity for actually executing a job and running through it. So the run job activity is the main one for this application, and that's what's invoked when somebody's looked at the list of jobs, clicked on one, and then launches the run job activity, which then uses some business logic, essentially the job processor, which will take the job definitions, parse them as needed, tell the activity what to display on screen. I'll come back to that in a bit more detail. So, as I said, we're using JSON for the task definitions. Now, there's not any major reason for choosing this over other things. The number of options you could have gone for XML or binary definition of something if you wanted. But JSON's nice and concise, it's reasonably human readable, and it's quite easy to parse as well. So that's what we went for, and I don't know if you can see it back there, but this is the most basic task definition we can have. It's a hello world essentially. So here we have this is the full task definition. There's a bit of metadata up here essentially. So that's the name of this task and description. So that's what we displayed to the user. And then the task consists of a number of pages. The page has a title and a number of items on it. In this case, we have one item, which is a label. See that by the type, proclaiming it as a label. Very imaginative, as you can see. So when that's, if this task was synchronized to the device and run, the user would get one screen on there with a hello world message being displayed from them, and then because there are no more pages, there would just be a finish button, so they click that and that would be the end of that task. So there's as well as labels, we have all the usual sort of input components, so text fields, numeric fields, date time inputs, drop-down lists, multi-select things, usual sort of stuff. So a workflow essentially is a number of pages, you find those, consisting of a number of items on them. Now, items have identifiers, so that you can refer to those values in other pages, other parts of the workflow if needed. Because obviously just a list of pages wouldn't be terribly useful on its own. You just have one flow through there. So you need some way of saying, okay, if the user's answered yes to this question, we need to do something else. So we also need some sort of expression language that we can have within our workflow, so that you can have a condition on this page to say, okay, if that data item has this value, then go to this page, otherwise go to that page. So that's essentially what the task definition is. It's a list of pages with some items on them, and those items can be referred to using a very basic and very clunky expression language used for this, but it's sufficient to say things like given that data item on that previous page, we'll do this, otherwise we'll do that. So a page would have we're not shown here, would have a reference to what the next page should be, and it could be any number of next pages. They would just be evaluated depending on the expression. There would be a condition associated with that next page. So It just then get executed in order. If the condition matches, then go to that page. If not, try the next one. If not, just default to the next page in the workflow. So the key bit for this application is or for this talk really, because we're here talking about dynamic interface aspect of it, is converting these items into things that are visible on screen that the user can interact with. One thing I've forgotten as well is that we have got a number of attributes that items can have as well, so you can things can be marked as read-only or multi-select, like that. That sort of thing as well, so they're defined within the task definition. So, going back to the activity, that's the main the run job activity is the main activity of the application, as I mentioned, and that handles the navigation basics, so the next and previous buttons that are displayed at the bottom of the screen, and it's also responsible for actually drawing the current page on screen and handling the Android state transition. So Android has various states that your application can be in. The main one most applications are concerned about are the create state, which is called when your the activity starts, or when you change the orientation of your device. So if you go take from landscape to portrait, it will re-invoke that with a bit of extra info, and your app can then react accordingly, because it may be you want to use a different layout when you're in landscape mode as when you're in portrait mode, to make use of the wider screen real estate. So this activity handles those things, but it doesn't actually have any real knowledge about the workflow or how to handle that. All it knows is, I need to draw stuff on screen. What does it need to draw? It delegates that to the job processor and a widget factory. So we have the job processor, and the activity will go, right, I need to draw the page. What am I drawing? Request the items from the job processor, and then we'll use the widget factory to convert those into actual native Android UI components. And the widget factory will do the actual inflating of the XML into the on-screen components. So the job processor is what deals with essentially deals with the workflow. It maintains your current position through the workflow. So click next 3 times, knows which page you're on, and it also knows which pages you've come from. So if you click previous, it'll take you to the one you just visited, not just the one that happens to be previous in the task definition. It also handles, invoking interpreting the expressions and using the values that have already been entered to work out what should come next. So it does. It's registered with the content provider as well. So as you're going through the application, going through the workflow, when you've finished with the page, anything that the user's entered into the items there, those values will get persisted to the database, so that when you come back to that screen, you have those values there again, and those values will then be sent to the server as well when the job's completed. So this is the sort of heart of the application in terms of working out where you are in the workflow. And as I mentioned before, we're storing the task definitions rather than converting the JSON to business objects as soon as it comes in. They're only interpreted as they're needed. So the job processor also invokes the JSON parser, which will convert those definitions for the current task into business objects, POJOs really, represent the page items, pages, and so on. and can operate on those. And that's what it'll send to the run job activity when it's asking for the current page. So here's a list of objects, render these, and the run job activity will actually create the widgets for that to display it. And that's the crux of how we have a dynamic user interface with one application. It's the definitions are converted to objects which will be manipulated and then converted to native UI components. One thing to point out is that there are actually two JSON parsers in use in this application, because the Android, what's provided by Android natively has changed across the various versions. So when we started this and Android 4 didn't exist, tablets ran Android 3 and phones ran Android 2.3, and Android 2.3 didn't have a useful native JSON parser built into it, so we used a third-party one, the Codehouse Jackson parser. It's quite straightforward, but it has a tendency to be a little bit slow. When with Android 3 and above, there's a native JSON reader functionality in Android. So if we're running on an Android 3 and above device, we use that version, which gives us performance improvements, but has the old Jackson one as fallback if needed. And that's one of the another nice feature of Android is that you can write one application that can support multiple versions of the Android operating system, take advantage of the new functionality that's there on the newer devices, but fall back to other methods on older phones, rather than having to develop multiple versions of the app and deploy them separately. Now, the Android provides a pretty decent set of standard components. So, text boxes, drop downs, or spinners, as it calls them. Your application can make use of those, and that's great. But for our use case, we were using a lot of things together. In combination all the time, so instead of just having a text box, the text box is always going to have a label associated with it. So we created a number of custom widgets, which are, for example, labeled edit box, which combines a number of the Android native components into one new one, and you can then use those exactly as you would any other component in your application. So rather than having your application always dealing with the low-level bits, you can build those up into useful bits of functionality and then apply those. So so that's what the widget factory does. Depending on what type of page item we're processing, it'll inflate one of the native, one of the custom widgets that we created. In addition, wrapped various common attributes like the read-only functionality and things. So we have a widget wrapper, so even for those, when we're using a native UI component, we'd have a wrapper around that so that if the task definition called for that component to be read-only, we'd have a common place that we would set up that functionality. And this allows to abstract away some of the details of, say, making a date field read-only or only display the time part of it. Abstract that away a bit so you're not having to deal with it at such a low level all the time. Where Android did have a bit of a failing in its native UI, I'm not sure if it does now, I haven't looked at it recently, is the multi-select spinner. So when you're selecting from list options in Android, has a component called a spinner, which is either a drop-down list or in the or actually rotating. Looks like a rotating thing. Depends on the version of Android you're using. But that only lets you select one of the items from the list natively. Because if you think about the Android, if you think about touch interactions, once you touch on something, it tends to, that's you making a choice, so it triggers that event and moves on. So what I had to do was develop in order to be able to select from multiple things from a list, I had to develop a custom spinner, which was essentially a custom pop-up that would allow you to take the page items and display them in a list there, so you can have checkboxes next to them and select 2 or 3 options. In this particular workflow, it was an example that would be when they're asking about any disabilities people may have, there'd be a list of things to check from. Obviously, they're not exclusive, you'd have more than one thing to choose from there, so that's one of the areas we had to enhance what Android gives you natively. So that's pretty much it, really, in terms of how this problem was solved. We were using JSON task definition to define what the workflow actually is, and that is synchronized to the device using the Android SyncAdapter functionality. The application itself then becomes essentially a template layout with some custom interactions there, so next to the previous buttons, but it doesn't know what it's going to be displaying until you've got a task definition to feed into it. And so we take that task definition, we parse that, know what page items are going to be displayed. Those page items we then map to Android native components and custom widgets as we need to. So last points there is just really just the sort of flow goes through. What having completed this, a number of things that you can take away from it. But reinventing the wheel is bad there, because essentially what we've done with the app is create a page markup language, expression touch for that, and rendering front end for that, which sounds an awful lot like HTML, CSS, and basic web technology. So essentially developed a cut down and probably much less well thought out version of that. But that's not to say that you shouldn't do that. So there would have been drawbacks to actually using HTML for the application, and you can learn. Let's not forget this started as a learning exercise. You can learn a lot by reinventing the wheel. One thing I wouldn't recommend at all is doing your own expression language unless you can absolutely avoid it, because it can be a pain to parse things correctly and validate it all and so on. In retrospect, probably should just use JavaScript or something like that for the expressions in the workflow, particularly since it's possible Android ships with a pretty efficient JavaScript engine called V8, and it's possible to hook into that outside of a web view. So if I was doing this again, I'd probably remove our custom noddy expression language and put something a bit better in there, whether that's JavaScript or something more suitable. I couldn't say. And also, one thing I learned is that Android provides some pretty great functionality out of the box. It really simplifies how you go about developing applications. So, the main ones being the synchronization and content providers in this example. As I say, data synchronization with the server just becomes a matter of saying, give me make this request, and it'll make that request, when it can, and you don't have to worry about it too much. Similarly for the content providers, it allows you to do things in a much more event-oriented model than you don't otherwise do. And also the Android UI approach of having activities for as main bits of functionality in your application, and the UI being XML definitions that you can inflate on the fly, and build up components, groups of components from other atomic components, aided greatly in being able to actually do this application and have a dynamic user interface, rather than having to hard code it essentially, and have a different application for each workflow. And finally, one thing worth pointing out is that the learning resources for Android are really first rate. Google has got a fantastic wealth of information up there, and it's being improved all the time with each new release of Android. They even have design guidelines for how to make your application look native. But it's just an absolutely fantastic wealth of resources, and it wouldn't have been possible to do for me to learn the Android fundamentals so quickly and develop this application without those resources. If you're at all interested, the code for this application is open source and is on my GitHub page at the top there. If you want to learn more about Android itself, the developer resources are there. And there's final links. One thing I didn't talk about was the actual there's background information, how did the authentication of the requests from the client to the server. So it's using a essentially OAuth style hashing algorithm around the REST API. Didn't cover that in the talk, but I was planning on it. Anyway, that's all. Any questions?
If you were starting the same project now, would you take the same approach given the state of Android and Android devices now? Would you carry on building native UIs, or have the WebView components improved to a degree where you could use those? Would you do it differently?
It depends what Android devices you need to support, really. One thing Google have been doing more of is updating components of the OS outside of the actual operating system environment. So from Android 4, the revisions of that, if you've got an Android device, you'll often see it going, here's an update to the Google Web App, whatever, and that's actually updating system library components as well to backfill functionality that's being introduced in a later revision of the OS. So the WebView side of things is better now. Particularly the offline side of things, and the V8 JavaScript engine is much more accessible now than it used to be. So if you're only targeting Android 4 onwards, then probably would take that approach. Alternative approaches. As I say, when I started this, it was 2.3 on phones and 3.1, I think it was, on tablets. And there's whilst Google strives for backwards compatibility with a lot of the functionality or fallback versions of things, it's not always possible to access things the same way. So I think you possibly run into the issue of having to have two different
Sure.
apps. Maybe that's a perfect acceptable trade-off. If you're controlling the devices that your users are going to be using, which in this case they were issuing people with tablets, then you can say, right, that's the version we're supporting, and nothing before
Or at least you could be confident that it wouldn't be anything older than that.
Yes, yeah.
You can save a lot of development costs by buying new kit.
Yeah.
I guess you're not really using the SQLite SQL feature because it's JSON stored in there, so you could have just used a basic index DB type database.
Yeah, I mean, it's a bit of both. So the definitions were being stored in JSON and then read out and parsed as needed, and the results of that parsing were cached during the life cycle of that workflow instance. So when you're working through a job, it doesn't have to re-parse things. When you go back to a page, it's cached that. The data items and metadata are stored in a more relational way, and so they would be, I guess so. Yeah, there's no reason that couldn't have been. You wouldn't necessarily have to use the SQLite. The content provider does work with any of the data stores or most of the data stores that Android provides. So you could have used one of the alternatives. That's one of those things. Once you start down one approach, you tend to, having decided to use the SQLite database, it's like, well, you put everything in there rather than.
Just a couple of years ago, SQLite with the HTML5 was really, you could have done it, but unfortunately they killed that approach. So.
Yeah.
And what do you do about data cleansing? I mean, does it load all the data when you sync at the fire station? Because there didn't seem to be any. I mean, the user did log in. Is there some notion on the server that these jobs are allocated to that user?
Yes,
so they
yeah.
only load to his, at that point that he's logged in.
So one of the things I haven't talked about is the user authentication side of things. So this application registers with the Android account management side of things. So when you first launch the application, it goes, there's no account set up, and prompts you to log in, and then that uses the Android account management stuff to store those details in the same way that if you look at your Android phone, you have your Gmail account there under the main settings and your Facebook and whatever. When it makes the request to the server, that's where this HMAC hash comes in. It's essentially hashing your user credentials, with your request to send that to the server, and the server can then, so you say there's a request from this user, and here's the hash to prove that it's this user. The server does a similar thing on their side to validate that, and then says, right, it's user Joe Blogs, we've got 10 jobs for him. Those are the ones that get synchronized to that device. So what's stored on the device is only the task definitions and jobs that are applicable to that user, and any data that goes with those jobs.
So at the beginning of the sync, the database is cleared out, is it? And then what data you get? It's getting a bit detailed. I just
the way it works is when you it's a little bit clunky. It doesn't support multiple user accounts on one device. You'd say you delete that user account and create a new one on there, and that would clear out the database for the completely, and it syncs stuff from there. So ordinarily, when it's syncing, it's only syncing things that have changed, and so what it sends to the server is only the completed jobs, and what it gets back is only the updated jobs. Or the server can also say, that job's been marked as removed, so removed from the system. So that's just storing what's needed in there.
You said you're using XML to inflate the widgets. Could you have done the same without XML, so just programmatically?
You can work. You can create Android components entirely with code. That's perfectly fine. That's what you used to. That used to be the only way back in the early 1.6 days of Android. But the XML, the inflating approach is actually more efficient because it allows the OS to cache various aspects of it and things. So that's the recommended way for doing it now. What that then boils down to is you can define your widget in XML and call, it becomes one line of code to inflate that. You call your resource manager to get your XML definition and then call inflate on that, passing in any other data it needs.
Yeah, so you pass in properties, so you
Yeah.
placeholders within XML.
Essentially, yeah. But what you then end up with is you still have an object, once you inflate something, you still have an object reference to it, so that you, once it's displayed on screen, you can programmatically do stuff on, to that object and have it reflected on screen.
Also, do you look at Ognal at all for expression languages?
Oh, what, sorry?
Ognal, OGNL?
No,
Object Graph Navigation Language, I think it is.
no, I've not heard of that one.
Many projects can switch back to that.
Yeah. Yeah. As I say, it was what we actually used was so at the Westminster Fire Service we had this web-based workflow platform called Activity System, and the expression language that we used for this is the same one we were using in that. So essentially stripped that part out and used it for this. Saved a bit of time. We were familiar with it, but it's not good.
Got the right answer.
Yeah.
Did you actually get the benefit of workflows changing a lot and being new ones being introduced?
Yes, one of the things, and this, one thing I should point out is this application is in use currently by Staffordshire Fire Rescue. West Midlands, as far as I know, haven't deployed it yet, but they have other plans for it. But what Staffordshire do is they have various safety campaigns that run every few months or so. So there'll be a block, various sets of questions that they want to ask only for those, only when they're doing home fire safety check, when those campaigns are running. So what they'll do is update the task definition to add those questions in, and so during the month of May, whatever the safety campaign is, that month will be an extra set of questions that will be asked as part of that. And the way it's handled within the application is that the task definitions have a version identifier, so that if they've got jobs outstanding for the previous version that has the old questions in it, they'll still get completed with the version that it was when it was requested, but any new jobs will have the new version. And they have a related field to do with fire safety, is where they go out and do assessments to commercial buildings and what have you. That was what when I left, that was what they were ramping up to do to develop the workflow for that. So they're now having two workflows available, and if somebody was on the commercial fire safety team, they'd only have jobs for that type, and if somebody's on the home safety team, they'd have jobs for the other type, but the one application then supports both workflows. Okay. Well, thanks very much.